Hey guys, this is Shivam from EECS 1021. Hope you guys are doing well. So some of you in class mentioned today that some of the lab material was a little bit tough to get started with. So this is an attempt to kind of ease that learning curve for you just a little bit. You're still going to have to work hard in the labs, but hopefully this tutorial will give you a little bit more background on what the fidget is, why we're using it, why we really care about this stuff. So as you might know already, the fidget is a microprocessor. It's a small little computer that has all the functions that a computer regularly has. It has inputs, it has outputs, it has memory, and it has uh, the ability to execute logic. And that logic is provided to it by you, the programmer, by actually writing code. Okay? So what's really cool about the fidget is that it has all sorts of data acquisition modules embedded inside of it. So we've got three on this diagram right here. If we look at the fidget, this is the microprocessor. It's got the onboard memory and everything inside of it. But when it comes to the inputs, it has two distinct types of inputs. One is analog input and the other is digital input. So as we know, the difference between analog and digital is that analog is typically infinite, right? It's usually time series data, and it's either voltage or current that's going to come into the fidget, and we're going to measure it. So examples of analog input are microphones. They could be temperature sensors. They could be voltage sensors. Anything that has an analog waveform or time series waveform is analog input. Okay. So in the Theremin lab, when you were measuring the voltage from the voltage divider circuit, that came in as an analog input. Okay. And digital input is opposite. It's either on or it's off, 1 or 0. So if you press a button, chances are that's a digital input. If the button is on, it'll return 1. If the button is off, it's going to return 0. So these are the sensors that are externally attached to the fidget, and you write code to read the values of those sensors. So that's kind of how that works. Okay. On the other side, if you want to actually actuate something using a digital output sensor, you'll send a digital 1 or 0 to the sensor to turn it on or turn it off. So this might be a switch. You might actually turn that on to actuate a particular sensor, or for a motion sensor, if you detect that you want to trip an alarm, that's what the digital output is used for. So now you know the difference between analog and digital, input and output. The fidget is the master controller where all the action takes place, and you provide the logic in order to operate your system. So this entire thing that we see here is your system. Okay? And the reason why microprocessors are so important is because of their cheapness and because they're so small. So obviously, you guys know about Raspberry Pis and small Arduino processors. Those are really cool little gadgets, little microprocessors that we can actually throw into the field. So instead of a motion controller being very, very bulky, a whole computer, these Raspberry Pis that are supercomputers on a chip can actually do the same functionality for you using all these analog and digital inputs and outputs. So that's a little bit brief history of the fidget and why it's being used. All right, now what I'm going to do is actually pull up Lab 2, and we're going to go through this code together to give you a sense of the architecture of how the fidget works. Okay, so if we go in this class, we see in the constructor, you don't need to worry about this. This is just a method called to send some debug information to the hardware interface. This particular line of code initially instantiates a new tone emitter, and then we get that over here. So this is important. This is a timer, and we're setting a delay of about 1000 milliseconds, which is 1 second. Now what's important to notice on the fidget is that this timer callback executes continuously until you stop the program. So if you set this to 1 second, this method will execute again and again and again and again every second. So if we go into this code, we're going to print out playing C, set the volume, play the middle note C on the piano, And first we're going to turn the volume on, then play it, then I'm going to turn the volume off. And we set the timer again here. So this is basically a never-ending loop, and we're just going to continue to play the note C again and again. So what's important to realize is when you run this program, the timer callback, because we're calling and setting the timer again and again over here, we're always going to be running this particular code. It's always going to be running in its own thread. What's important is this method over here. We see public void analog input changed. Now from the method signature, you should be able to figure out that this is actually sensing, if we go back to this document or this diagram, it's sensing whatever changes in input we're going to have here. Okay, so if you imagine my voice as a microphone, if I raise my volume suddenly, you'll see the amplitude of the signal rise. And if I go really, really low, then the amplitude tends to kind of die down a little bit. So all of that is being sensed by this particular method. Okay, it's listening. It's actually implemented as a listener, but it's listening for any change in analog input. So any sensor that you have attached to the Phidget board, if there's a change on it, this is going to record it. And it's going to print out the analog input change event, which is over here. Okay, so if we go into the API, which is located over here, so if you type this in Google, EECS 1021 URQ, click on any of these, then go to the C4E API. If you go down the hardware interface, what you'll see here in this API is a list of all the methods that are supported by the Phidget, and this is the class that you're going to interact with most. So this description says a callback for a change event in any of the analog inputs. So it pretty much confirms exactly what we were thinking. If we click on the event, which is another object, these are the types of attributes it has: an analog input change event, a detach, attach for any other external hardware, and a digital input change. But more importantly, if we get down, these are the functions that it supports. Okay, so we can get the ID of the port that generated this event. So let's say we have a temperature sensor that's connected on input 1 and maybe a voltage sensor that's connected on input 2. This is going to tell us which ID generated the change. So it's useful if you have multiple analog inputs or digital inputs, depends. Okay. These three values are extremely important as well. Get value is going to determine the value that's associated with this event. So if we click on this, it'll tell you for digital events, as we discussed earlier, it's going to be 1 or 0. And for analog events, it's going to be a real number. So for the microphone example, it might be the amplitude of my voice. If we're measuring voltage, it's going to be the magnitude of that voltage. Okay. Get when as well. This will give you the timestamp of when this is going to happen. You're going to have to do some calculations to calculate what the current time is, because it's going to give it to you as milliseconds since 1970, but there's many ways on how to do that. You'll cover that in the different labs. Okay, so the point is, if we go back to this code, in this EPUB, two things are running concurrently. This is always going to run. Whatever you do in this method is going to run at the frequency of the delay that you initialize in the constructor. Okay, so this is 1000 milliseconds. So if I put this to 1, it's going to go every millisecond, which is way too fast for the Phidget. So just keep this to reasonable amounts. And if you increase this to 10,000, then we're going to go in 10 seconds. So maybe a little bit too slow. And whenever there's a change in the analog input, it's going to pop up over here. Okay, so when you changed frequency or volume with the theremin gloves, that would be reflected over here if you chose to print this out. Okay, If you copy and paste this method and you change analog input changed to digital input changed, it would be the same thing except in terms of digital inputs. So it separates the analog from the digital inputs. Okay. So hopefully with this small explanation on the Phidget and how the threads work by themselves, I hope that gives you some sort of ammo to go into your lab with. But if you have more questions, you can feel free to email me or bring up any questions in class. Good luck, guys.